Hi, my name is Nick Borson, and in this video I'm going to talk about the difference between value types and reference types in C#. So value types are uh, integral and floating point types, Boolean, character, so those are kind of the built-in value types in C#. And then you can also define anything you define using as a struct or as an enum. Those are all considered value types in C#. Reference types are the built-in types are things like string, anything that's referred to using the object keyword or the dynamic keyword, and any user-defined type that you define as a class, interface, or a delegate. Those are all considered reference types in C#. So what does that mean? Well, I'm going to walk through a few things here. So the first thing I'll talk about is the difference in assignment semantics between value type and a reference type, what it means when you assign one variable to another. That's different depending on whether it's a reference type or a value type. Then I'll talk about memory and lifetime, where the objects live in memory, how long the objects live, whether it coincides with the execution of the code or whether it's garbage collected. And then there's several related concepts that it will get to at the end, including boxing, which is conversion of value types into reference types, reference equality versus value equality, whether we are comparing the values of objects or their identity. And then also there are a couple of keywords in C# that allow you to pass parameters by reference using the ref or out keywords. It's really kind of not the same thing. It has nothing really to do with value types versus reference types, but it still has this concept of reference that we'll get into. So the first thing that's different between value types and reference type is, and kind of the most visible thing in your program, is what happens when you assign one thing to another. So here we have, we're creating a variable a of type t, whatever t is, and then we initialize variable b by assigning it, by assigning a to b. So what that means, what that does, depends on whether t is a reference type or a value type. If t is a value type, then variables a and b are different objects that have the same value. So it's a value assignment, copying the value. If t is a reference type, then a and b are references to the same object. So there's only one object, and a and b both refer to that one object. So there's a level of indirection with a reference type, that a and b are referring to something that is independent of those variables. And also there's this concept of object identity, that there is one object that a and b both refer to. And the same thing that applies to assignment also applies to any place where an object is either copied or a reference is copied. So whether you're passing a parameter to a method or returning a value from a method or assigning one variable to another, the same concept applies. So let's go ahead and look at a demo. So to demonstrate assignment semantics, the difference between reference and value assignment, I've created a simple C# console application here in Visual Studio. And everything is in this one source file. At the top of the file, I've defined a structure called myStruct. So I've used the struct keyword. And it's a very simple structure. All it has is one public property of type int, which you can get and set. So it's a gettable, settable property of type int, and its name is value, and it's public. So that is the entirety of my structure. Then we have a class called myClass, again with nothing but a value property of type int. And the only difference between these two types is that myStruct is defined using the struct keyword, so it's a value type, and my class is defined using the class keyword, so it is a reference type. So let's go ahead and look at what happens when we assign these types. So here we have the program class, which only exists so we can have a static void main function. So the main function has to be static, and it is the entry point of the program. So when we start running our program, we will begin executing at the body of the main function. So inside main, we create a new myStruct, and we initialize its value property to 10, and we assign that to variable a. So a now refers to a myStruct in which the value property is 10. Then on line 16, we initialize variable b by assigning it the value of a. So because a is a value type, a structure, the assignment here is copying that value. So A and B now refer to two different objects, two different structures. One of them and both of them have initially the same value. Then the next two lines simply output the value properties of the two objects. So a.value is equal to the actual numeric value. So this is using string interpolation in C#. So we're using the console write line method to output to the console. Inside the curly braces is an expression that we evaluate, and its value is inserted in place of that expression. That works because of the $ in front of the quotation mark here, which means we're enabling this this convenient interpolation. So we output a.value, we output b.value. Then we're doing the, and of course they should be the same. Then we change the value property of a by setting it to 20 without changing b. Now we output both a and b again. And in this case, we should see that A's value property is now 20, but B's value property is still 10. And the reason that's the case is because A and B are two different objects. So let's go ahead and run our program. And again, the first two lines, we have the initial values, so A and B are both 10. And then the last two lines is after we've set the value property of B to 20, or excuse me, of A to 20, and we see that indeed A is 20 now, but B is still 10, and that is reflecting the fact that this is a value type, and so A and B are two separate objects. Modifying one does not modify the other. So what if we change now to use a class? So we'll say my class, and we make no other changes to our program. Now the difference here is that we've initialized A to a new object of type myClass, given it value 10, and then in the assignment here, because a class is a reference type, what we're actually doing is not making a copy of that class. We are initializing B to be a reference to the same object as A. So A and B, there's now only one myClass object, and A and B both refer to that same object. And of course, when we output the value property of A and B, it's going to be 10. But now when we set the value of object A to 20, the value property of object A to 20, when we output the result, we're going to find that the value property of both A and B is 20. And that's because there is only one object, and A and B both refer to that same object. So let's go ahead and run our program just to demonstrate that. Come on, you can do it. There it goes. And so we see initially A and B are both 10, and then after we change A's value property, we see that both A and B are 20 because they are in fact one object. So that is the difference between value assignment and reference assignment. And the same concept applies if we are passing parameters rather than assigning. When we, if we create a function, let's change this back to a struct. My struct. Okay, and we create a function, static void func. And we'll just say my struct obj. Okay, and we will say, I'm going to say obj.value. Okay, I'm going to say obj.value equals 20. And then we'll output that. All right. Okay, so what we're doing here, we are creating an instance of myStruct and assigning it to variable A. We output its value. We pass that structure to the function. Inside the function, we change its value to 20. We output the result, which should be 20. Now we return back to where we came from. We pick up where we left off after the function call, and then we output the value of A. Now because this is a value type, when we pass it to the function, we are passing a copy of that object to the function. So when we change its value inside the function, that does not modify the value of a. So when we output the final value at the end here, we should still see 10, even though the value is 20 inside the function, because they are two separate objects. Again, because it's a value type. So let's go ahead and run our program. And so here we see, again, in main, the initial value is 10. Inside the function, we've changed the value to 20. But when we return back to main, the value is still 10. So if we change this to a class, let's change this to a class in both places. And then we run our program again. Then we see that the initial value, of course, is still 10 when we create the object. Inside the function, we set the value to 20. Then when we return back to main, the value of a is 20. And the reason is because when we pass the class, the reference type, to the function, we are passing a reference to the object. We're not creating a new object. We're not copying the object. The obj variable inside of the function is referring to the same object as the a variable in main. So when we change its property to 20, its value property to 20, and return back to main, that same object now reflects that new value. So again, reference type is passing a reference, or is having one object and passing a reference to the object, whereas a value type is always copying an object. And that applies whether you're returning something from a function, passing a parameter to a function, or assigning something, as in the first example I showed. Okay, so we've seen how assignment works differently between reference types and value types. Let's look at how these different types are represented in memory. This will give us a little bit of an idea of how these types work under the hood. So here I've just created a simple, I'm just showing a simple function called f, that, or method, that has two local variables, a and b. A is a value type, in this case it's just an integer. Could be a struct, could be something else, but in this case it's just an integer. B is a reference type of type myClass, just like we showed in the demo a minute ago. So the difference between how these are represented in memory is that the value type for a local variable is stored directly on what's called the stack. The stack is just an area of memory that's used for local storage of methods, as they're called. When your program starts executing, or when a thread within your program starts executing, the operating system creates an area of memory called the stack that is used for local storage. As each function, as we enter a function, as a function is called, then a stack frame is created for that function, pushed on top of the stack, and that stack frame includes the return address of the function to return to, where in the code to return to after the function returns, and it also includes parameters passed to that function, and it includes the local variables within that function. If it calls another function, then another stack frame gets created on top of that. It's sort of a last in, first out. When the function returns, its stack frame gets popped off, just like a stack of plates. You put stack plates on top, and the last plate you put on is the first one you take off. So that's kind of how the stack grows. It's in a very orderly fashion. It grows last in, first out. So value types are simply stored directly on the stack, and this is possible because the lifetime of the value object is tied directly to the code flow. When you return from the function, there's no references to that value object that are potentially dangling, that somebody else is going to be referring to, because value types are not referred to by reference. Reference types are different because you can create an object of class type, say, within a function, and return a reference to that function, and we expect that object to continue to exist after the function returns. So the objects of reference type cannot be created on the stack. They are created on something called the heap. The heap is a place where is an area of memory that is managed in such a way that you can allocate objects and free them in any order. So the last one allocated doesn't have to be the first one freed. There is a separate piece of code called a garbage collector that periodically wakes up and finds objects on the heap that are no longer have any references to them and cleans them up and returns that memory and makes it available again. So that is how objects of reference type are created. That's where the memory of those objects is stored. And that's what allows you to have any number of different references to the same object, and for the lifetime of that object to extend even after the function that created it has returned. Now you still have the reference itself. So you have, for example, here in this example, we have variable b that then refers to the myClass object. So there's the object itself that's stored in the heap, but b, the reference to the object, is stored on the stack. So if we look at that visually, here we have a stack shown on the left side, and the kind of gradient area is just where I'm imagining a whole bunch more stack frames of whatever functions have called f. And then the stack frame of f is on the top. It's the we have within its stack frame we have the return address. So that's not something you actually see as a programmer, but that's how when f returns, how control is returned to the point in the code of the calling function where it left off. And then we have the local variables a and b are stored on the stack. A is just the value itself because it's a value type. So the integer 10 is just stored directly on the stack. But b is a memory address, which I've represented here as an asterisk. Memory is just simply laid out as like a sequence of boxes, and each box has a number, and an address is simply the number of the box. So B contains the address of the object itself, which lives on the heap. So on the right-hand side, we see the object itself. There's a hidden pointer inside the object that contains type information. That's how the we don't see that as a programmer, but that's how the runtime knows what the type of the object is. And then we have the actual fields of the object. In this case, the integer property are stored as part of the object as well. Now the same thing applies. You can also, in addition to having local variables, you can have members. So you can have one object that contains a member of some type. So let's take a look at that. Here we have a class, so a reference type, a class that's of type pushPin. So I'm imagining a pushPin on a map. And let's say that we have two properties. One property called coord is the coord. Short for coordinate is the XY coordinate of that object on the map. And another property called style is a reference to an object that defines something about the appearance of that pin. So maybe it has the color and the type of pin head, whatever. So I'm just assuming pin style is a class here, and vector2 is actually a class in the .NET framework in the system numerics namespace, which is a struct. It just consists of an x and a y coordinate. So coord, in short, is a value type, and style is a reference type. So when we imagine what this pushPin class would look like in memory, this is what we get. We have again, the hidden pointer to the type information, which we'll ignore. Then we have coord, the value type, is stored directly in line as part of that pushPin object. So we have the two coordinates. Let's say x is 100 and y is 25. They're just stored directly in line. Just like if coord was a local variable, it would be stored directly on the stack. Because it's a member variable, it's stored directly in the containing object. Style, on the other hand, is referring to is a class member, and so the object contains a reference to the pin style object. So part of what that allows then is we can have multiple pushPin objects all that refer to the same pin style. And because it's a reference type, we can have one pin style object that's shared by any number of pushPin objects. Whereas each pushPin object is going to have its own coordinate because it is a value type stored directly within the object itself. So that is how the memory and lifetime differ between reference types and value types. And it has to be said that most types are reference types because it has the most flexibility. You can do more things with them. You can create these relationships of objects that are linked together in various ways. Value types tend to be used for very simple things like numbers, or in the case of vector2, it's just a pair of numbers. a coordinate or a matrix or something like that. Very simple things. It's very efficient to use them because you don't have to allocate memory on the heap for them, but they tend to be used for short-lived, simple values that you're calculating with, as opposed to objects that have some more extended lifetime. Okay, we've talked up to now about how sometimes we have two references to the same object. In another case, we have two variables that refer to different objects that have the same value. So what do we mean by same object versus same value? Well, to get into that, we have to talk about how we compare objects for equality in C#. So every object has an equals method. Well, actually, let's start with talking about reference types. Every reference type has an equals method that it inherits from the object class. The object class is kind of the base class of every class in .NET. And the object class has an equals method. So here we've defined a class called myClass, and we've given it a value property, but we've given it nothing else. But it still has an equals method, as we can see down here. So here I've created 4 objects. R1 is initialized to the value with the value 5. R2 is a reference to the same object as R1, so that's reference equality, right? R3 is a reference to a different object, a new object with the same value as R1. And R4 is a reference to yet another object with a different value than R1. So this will allow us to compare what equality does in all these cases. Now, so far I have not defined an equals method for this class. So let's just see what the default behavior of equals is in all these cases. So I'm going to go ahead and build and run this program. And we'll run it here. And let's just look at this side by side. So we see that, R1 equals R2 gives us true because they are in fact the same object. So that's reference equality. R1 equals R3 gives us false. Even though they have the same value, the value property is the same. The default implementation of the equals method is just comparing for reference equality. It's just checking if they're the same object. And so it returns false. And of course, we expect R1 and R4 to not be equal. And in this case, it's for the same reason, because they're not the same object. So what if we want to redefine equals to give us value equality instead of reference equality? Well, we can do that by overriding the equals method on our class. Like I said, every class inherits an equals method from the object class, but we can override that method to do something different that is more appropriate to our class. And in some cases, reference equality is fine. That's all you need. But if you want to have your class behave more like a value, you can define equals to mean value comparison. So let's go ahead and do that. We'll say public, and we're overriding the base method, so we use the override keyword. Except I have to spell it correctly. Override. And when I type override, then the Visual Studio knows that there are 3 potential methods that I could override, because those are the overridable methods of the base class. So I'm going to override the equals method. I'll just double click on that. And it creates a default implementation for me. And we see that the equals method takes a parameter of type object question mark. So object just means that the argument that's being passed in could be any kind of object. We don't know what kind of object it is. So that's the sort of the root base class of all objects. And the question mark means that it could be null. So we need, in order to implement the comparison we want to do, we need to know whether, first of all, it's not null, and second, whether it has the same, whether the value property, well, second, whether the type is whether the actual type of the object is the same as is in fact my class, and third, whether the value is the same, whether the value property is the same. So there's a distinction here between the actual runtime type of the object and the static type of the variable. Sometimes when you pass a parameter or something like that, you lose type information, you lose the static type information, but you can still determine at runtime what the actual type of the object is. So to do that, we could cast it like this. We could say my class obj, But if we did that, that would throw a invalid cast exception. It would throw an exception if that object was not of that type. What we really want to do is just if the object is of my class, we want to return and has all the other and has the same value. Then we want to return true. In other cases, we just want to return false. So we can use the as operator. We can say obj as my class. Let me put that in parentheses. So what that's going to do is it's going to yield a reference of type my class to the object if it is not null and the actual object, the actual real object that we're pointing to, happens to be of my class or of a type derived from my class. So if that's the case, then we want to compare the underlying objects. Now I can use, so if that's the case, so let me do it in a verbose way, and then I'll do it in a more concise way. So we'll say var other equals, okay? And we see now that other has type my class question mark. So in other words, it could be a my class or it could be null. So then we can say if other not equal to null, then return other.value equals value. Else, return false. Okay, and now we know that in this block here where other is not null, we know that it's not null. So the compiler has been clever enough not to worry about the fact that we're using the dot operator here, and we can then just compare the values, or we can say other.value dot equals value. Value here is equivalent to saying this dot value. We're returning the value property of this object. Now we could do this more concisely. We can say, we can use the null conditional operator. So we can say, we can do this whole thing in one line. You can say return, lost my keyboard. Return obj as my class. You can use the null conditional operator. So we say so question mark dot value dot equals value. Okay, so this part to the right of the question mark, the part to the right of the question mark dot will access this property, the value property, only if the part to the left is not null. And then, of course, once we have the property, we can call equals on it to compare it with others. Now, if it is null, what happens? Well, we can use we can evaluate the whole expression to null in that case. But since we want a Boolean, we can use the question mark operator to supply what the value of the expression is in that case, in the case where. So this is really equivalent to the longer code we have below. So just a nice concise way of doing that. So if the object exists and is of type my class, then we're going to access its value property and compare it with this object's value. Otherwise, it's false. Okay, that was all fairly complicated, but let's go ahead and see what this does now when we run our code. So again, I'm just going to run the program. And now we have behavior that's more like what we expect. So when we compare R1 to R2 using the equals operator, we get true because they are the same object. When we compare R1 to R3, we also get true. They're different objects, but they have the same value property. So our equals method treated them as equal. They have this. So we're implementing value semantics for equality. And then, of course, R1 equals R4 is going to return false because the value properties are different. And I suppose we should test maybe another case. Does our equals method do the right thing if we pass it null or pass it some other type? So let's say we equals 5 or equals null. And I'm just going to comment out these others up here. And both of these should return false. So 5 should return false because what's going to happen here is the equals method takes an object, right? Well, so 5 is an integer. That 5 is going to be boxed. It's going to be turned into a box integer, which is an object wrapped around an integer, essentially. Well, that integer is the wrong type. It's not a my class, and therefore, when we say object as my class, that's going to return null, and therefore we're going to return false. And of course, when we pass null, that's not anything. So when we run this, we should get false and false. So let's go ahead and run it. And indeed, we get false and false. Okay, so that gives you an idea of how to override the equals method. One more thing I should mention, just because we see that there's a squiggle on the word my class here. If we hover over that, it says that it overrides object equals, but does not override object get hashcode. So that's kind of a no-no because those two methods should match in their behavior. So if an object has the idea of equality, then it should also have the idea of basically get hashcode is supposed to return an integer that is computed from the value of an object. Well, if you implement equals, that implies your object has a value, and therefore it should also have a hashcode that corresponds to that value. And since our value in this case is an integer, the hashcode can simply be that integer. So I'm going to just say public override get hashcode return the value. So hashing is just a way of computing an integer from some value that may be something other than an integer. For example, the string class has an implementation of get hashcode that computes an integer from the string. Now, obviously, there are way more possible strings than there are integers, so you can get hash collisions where two different strings yield the same integer, but that's rare. In most cases, two different strings are going to give different hash codes. And the key thing is that if you have two strings with the same value, they should yield the same hash code. And this allows you to very efficiently look up strings in a hash table. That's what hash codes are really for. Okay, but that's kind of a side topic. Okay, so we've talked about equality on a reference type here. There's one more thing I could mention, which is what if we compare these my class using well, okay, another thing is that there's always a reference equals method on the object class. There's a static method called reference equals. So I can also, if I want to, always compare whether two variables refer to the same actual instance of an object. So in that case, for example, even though we've implemented equals to say that R3 and R1 have the same value, if we want to know whether R1 and R3 are literally the same object, we can always call object.reference equals. And if we write that to the console, then it will output false because they are two different objects. Okay. And finally, there is the equality operator equals, equal. So we have not overridden that operator, so it is still going to be implemented in terms of reference equals. So if we say console write line R1, R3, then it's going to return false, even though so by default, the equals operator does not call our equals method. It just does a reference equality. Now we can actually override that operator, but some guidance I've seen suggests that that is not the correct thing to do for your own types, that you should just allow that operator to always mean reference equality. On the other hand, the string class, the built-in string class, does treat equals equals as value equality. So I would leave that to your own judgment as to what makes sense in your own code. So that is what that is how equality comparison works for reference classes. The next thing is, let's take a look at how we can compare equality between value classes. We've talked about comparing equality for reference types. Let's now talk about comparing equality for value types, because it's a little bit different. So let's go down here. We have our myStruct as a value type. And let's go back to the main method, which I've changed here a little bit. So now we have some different instances of myStruct. So v1 is an instance of myStruct with value 5. v2 is the same as v1. Again, this is a value type, so it's two different objects with the same value. v3 is another instance of myStruct with a different value. And just for completeness, I've added r, which is a boxed value, which again, a boxed instance of myStruct, which again is has the same value as v1. Now, here I have several calls to that use the equals method. So we say, we're calling v1 equals v2 equals v3 equals r and equals 5, which is, obviously just an integer. And what we're going to find is that the equals method is a little different for a value type than for a reference type. In the case of a reference type, the default implementation of equals inherited from the system object implementation, which did a reference comparison, whether the two objects were the same object. It was doing reference equality. Well, that's not appropriate for a value type, because reference equality kind of doesn't even make sense for a value type. Anytime you have two different variables, they're always going to be different objects. So instead, all value types inherit from a type called system value type, which redefines the equals method to do a member-wise equality. In other words, for each property or each field, I guess each property, it compares whether the corresponding property of the two objects are equal. So in a sense, equals really is going to already do the kind of value equality that we implemented on our own for the class type that we did earlier. So let's go ahead and run this program and see what happens. Okay, so this is the output we got. Let's take a look at how this lines up with what we expect here. So the first comparison, when v1 equals v2, yielded true. So that's kind of what you'd expect. These are two different objects, but they both have value 5. And so the default implementation of equals returned true. v1 equals v3 returned false, which is again what you'd expect. These are two different objects, but they have different value properties. So equals returned false. v1 equals r is kind of an interesting case, because here we have the v1 is an instance of myStruct. r is a boxed instance of myStruct, but again, it has value 5, and so when the equals method is going to treat that as having the same value, because it is, in fact, all of these cases get boxed when the equals method gets called, because the equals method takes the argument type is object. So v2, so in this first call, v2, in order to call equals, has to be converted to an object, which means it gets boxed. It means an object is created on the heap that wraps a copy of v2. And here, an object is, in the second call on line 33, an object is created on the heap that wraps an object of v3. And so line 34 is really the same thing. We've just already boxed the object and assigned the reference to that boxed object as the variable r. Line 35, we're comparing the myStruct with an integer 5. Now again, the integer 5 is going to get boxed, so it's comparing it with the boxed integer 5. Well, that boxed integer has a different type than myStruct, and since the types are different, the default equals method is again going to return false, and that's what we in fact see. So the default equals implementation for a value type is doing a member-wise comparison of the properties or fields to see whether they are in fact equal, which is kind of what would make sense for a value type. Now, one thing that I mentioned already was that we see that that these values are that in order for the equals method to be called, since it takes an object, we have some boxing going on, and that means that we're doing heap allocations every time we want to compare two objects, and so that's kind of not ideal. Actually, before we get to that, let me just point out one other thing, and that is that if we say v1, if we say object.reference equals v1 v2, then we see that the compiler, if I hover over that little green squiggle, it says do not pass an argument with value type to reference equals because due to value boxing, the call can return an unexpected result. So in effect, v1 is going to get boxed and v2 is going to get boxed, and reference equals is always going to return false because these end up being two different objects. Reference equality just doesn't really make sense for a value type. And furthermore, if I say v1 equals v2 using the equality operator, that equality operator by default is not defined for a value type. We can choose to define it by ourselves, and in fact, maybe we will in a minute. But before I do that, let me address this boxing question. So there's a performance implication to allocating these boxed objects every time we call equals. So if we expect to call equals frequently, we can actually define a different version of equals that that doesn't require boxing. So to do that, we can override the IEquatable method, or IEquatable interface, sorry. And this is a generic interface. That's why we have these angle brackets. So generic interface means that it takes type parameters. So it's not just an IEquatable, it's an IEquatable of some type. And the type in this case is going to be myStruct. So in other words, by implementing the IEquatable interface, we're saying that we have a method that allows us to compare this object with another myStruct. Now, see the red squiggle there says myStruct does not implement this interface member, so we can hit Alt-Enter to do that. Implement interface, we'll do that. And now it's filled in, it's added a placeholder method with a default implementation, which in this case it doesn't do anything, or throws an exception. So let's go ahead and implement the interface by just saying return other dot value equals value. Okay. Now you notice this is not taking an object. It's not taking or an object question mark. There's no question mark here, so that the other object is not a heap allocated object. It's passing it by value. So this is going to be more efficient to call. We're not having to do any boxing in order to call this. So now when we make these same calls, v1 equals v3, instead of going to the generic or to the equals, well, actually when I hover over this, before when I hovered over this, the parameter type was object question mark. Now it's choosing the overload that takes a myStruct, and so it's not going to have to do any boxing. And it should still behave the same way. When I run the program, if I like so, I still get true when comparing v1 equal v2, false for v1 and v3 because v3 has a value 10, true for r, and false for 5 because they're different types. Now actually those last two interesting. If I hover over I'm hovering now over line 39, and you see that that method is calling the overload of the equals method that takes an object question mark, because the parameter is of type object. So the static, even though it's a boxed myStruct, the static type of R is an object. And whereas the method that takes, the first two calls take an argument, or calling the overload that takes the specific type and that don't require boxing. Now this last one that takes the integer 5 is again calling the method that takes an object question mark. And the reason for that is because 5 doesn't match the myStruct, And so it chooses the overload that takes an object, and so it boxes the 5 and passes that object to that more general base method. Okay, so finally let's look at overloading the equality operator. So if we want to allow comparing the value type using the equality operator, we can simply define that. We can say operator equals, operator equals, oh, come on. Well, actually, it's public. It has to be static. Static bool operator equals. There we go. And it's actually going to autocomplete that for us. And so this is going to, so it takes two operands of type left, of type mystruct, the left operand and the right operand. We're just going to compare their values. Return left.value equals right.value. So we're going to return true if those values are equal and false if those values are not equal. And if I hover over, see there's a squiggle on line 13 there. If I hover over that, it says we've defined operator equals but not operator not equals. So we just go ahead and do that. I'm just going to copy and paste. So this is just to ensure that we're defining things in a consistent way. If we define equality, we should also define inequality. Okay, so now, previously I was not able to, I had to use dot equals. Now I can do this. I can use the equality operator. And likewise for this one. I still can't use the equality operator here because the types of the arguments don't match. So there's no equality operator that takes operands of type mystruct and object. So that one's not going to work. So I'm just going to copy that, comment that out. And ditto for 5. There's no equality operator. I haven't defined an equality operator that takes types mystruct and int. So I'm just going to copy that out. Comment that out also. So if I run my program now, we're going to see the equality operator in action. And actually this time I'm going to step here, and here I invoke the equality operator. So if I hit F11 to step into that, we see that, well, I guess it's just stepping over it. Okay, so the final thing I want to talk about before wrapping up is the idea of reference parameters and output parameters. These are parameters that are passed by reference. This is sort of entirely independent of reference types versus value types. This is more about the way that you pass a parameter, not specific to the type. So, okay, that was a poor explanation, but let's look at the example. So here we have two functions. F1 takes a string. It's a static function, takes a string. And F2 also takes a string, but in this case, the parameter has the ref keyword attached to it. We're going to see what that does. Here in the main function, we create a string s. We initialize it to the word hello. Then we call F1. We pass in s. Inside the F1 method, we now have a reference to that same string. We say s plus equals world. Now, an important thing to know here is that the string class in .NET is immutable. It cannot change a string in place. So when we say s1 plus equals world, what we're really doing is we're creating a new string that is equal to the original string plus the word world. So we're assigning we're creating a new string and assigning it to the variable s. Once we've done that, this variable s is now no longer referring to the same object as the variable s in the calling function in main. So when we call console writeLine here in F1, then we're going to write the new string that is hello world. Then when we return back to main and we call console writeLine s, we're going to write the original string, which is hello. Now F2 works a little differently. F2, we're passing s by reference. And to do that, we have to have the ref keyword both in the parameter declaration in F2 and also at the call site. And this notifies you when you're calling F2 that you are passing s by reference. What that means is that the function is actually allowed to modify the variable itself. It's not allowed to modify the reference to point to a new object if it wants to. And this applies whether S is a value type or a reference type. So it's kind of independent of the type. So inside F2, we're doing the same exact code as in F1. So S, the plus equals operator here is going to create a new string. And that new string will be hello world. And that new string will then be assigned to the variable S, but because S is passed by reference, that means the variable S in the main function is also going to point to that new string. So the output we expect here is going to be hello world written by F2, and then hello world again written by main. And when we look at the output of the program here, I've already got it open, we can see that here is hello world written by F1. Then when we return to main, S is still hello. And here is hello world written by F2. And then when we return to main, since we passed S by reference, hello world back in the S variable back in main is now also hello world. So that is what ref means. It means we're passing a variable by reference. And we can do the same thing for an integer, for example. Like, let's say that instead of an S, we have int n, and we say n plus equals 5. That's our right line n. And we'll do the same exact thing here. Okay, so now we're initializing the integer n to 0. Inside F1, we're going to add 5 to n, so n is going to be 10, or excuse me, it's going to be 5. But because we're passing a copy of n to that function, the value of n in main is unchanged. So the console write line inside F1 is going to print 5. Then we return to main, and we have main's copy of n is unchanged, will be 0. Then we call F2, but this time we're passing n by reference. So n is now a reference to n in main. Now there's no boxing here. N has not been converted to a reference type. It's actually, that parameter is actually pointing back to the value n in the stack frame of main. But so when we add 5, then n is now 5, and we write it, and so we get 5, and we go back to main. Because we passed it by reference, it is now reflecting the change we made inside F2, and so when we write it, we'll get 5 again. So let's go ahead and run this version of the program. And indeed we get 5 inside of F1, 0 inside of main after calling F1, 5 inside of F2, and then 5 inside of main after calling F2. So that is just what we'd expect for a reference parameter. Now an out parameter is similar to a reference parameter, except that the caller, or the function you're calling, is required to set the value, and it's not necessarily required to initialize the value before calling it. It's expected that the caller is always going to initialize that value. So an example of how that's used would be something like, it's used kind of in places where you might otherwise use a return value. So let's say add int a, int b, out int c. And we say c equals a plus b. Okay, so here inside of main we could say int x, and we don't bother initializing it perhaps, and we say add 5, 10, out x, console.write line x. And then when we run this, we should see we go into the main function. We've passed in 5 and 10 as a and b. C is set to their sum, so C should now be 15. And because it's passed as an out parameter, then that change is actually reflected in the value of x in main, because x is bound to the C parameter of the add method. So when we run this, we should write the value 15. Okay, so to summarize, in this video we talked about all the different ways that reference types and value types differ. So that starts with the semantics of assignment, including parameters and return values, passing parameters and return values, and assigning things. Value types, assignment means you're copying the value, whereas reference types means assignment means that you have two references to the same object. We also talked about the memory and lifetime, how reference types and value types are represented in memory. Reference types are always their own separate objects on the heap, whereas value types are stored in whatever the context is, whether that's on the stack or in line with another object. We talked about equality and different ways of thinking of equality. Reference equality, using the reference equals method, is sort of the default meaning of equality for reference types, although you can implement equality for reference types that compares values. For value types, reference equality is not really defined. It doesn't really mean anything. But the default meaning of the equals method for value types is to do a comparison of the individual properties. But you can also implement your own equality methods. We also talked in that context about boxing, how value types, sometimes if you convert a value type if you use a value type in a context where an object is expected, then that value type will be copied to a boxed object on the heap. And to avoid that, you just want to, if you want to avoid that, you can do so by using methods that take the exact type that you want. And finally, not directly related to reference and value types, but we talked about how there are such things as reference parameters, where you can pass have a parameter that's passed by reference, which means that the function that's being called, that parameter actually refers back to a variable in the context of the calling function. So so you can actually modify a value, whether it's a value type or a reference type. You can modify a variable in the calling function if it's passed by reference to another function. And out parameters are similar, except that they're specifically used for cases where the caller has to initialize the output parameter. So that's kind of the summary of reference versus value types in C#. This has been kind of a long video, so if you made it all the way through, then congratulations for your patience, and I hope you learned something useful. All right, thank you. Bye.